We're going to practice predicting precipitation reactions, whether or not a precipitate forms when two aqueous solutions are mixed. The procedure is that we note the ions that are present in solution, we consider all the cation to anion combinations, and then use the solubility rules to determine whether each of these is soluble or not. Take note that these are cation to anion combinations. The cations written first, the anions written second. In this first example, we see the ions that are present in solution are sodium ions and sulfite ions in the first aqueous solution. The second aqueous solution has aluminum 3+ ions and chloride ions. If you are having difficulty identifying the ions in solution, I suggest that you review the last chapter's material. The possible combinations, now again, cation to anion. So we have sodium partnered with chlorine, sodium partnered with sulfate. And we're going to write the formulas correctly such that the positive charges balance out the negative charges. Aluminum can be partnered with chlorine, and aluminum can be partnered with the sulfate. Apply our solubility rules. All sodium compounds are soluble, so these are soluble. Aluminum chloride. Most chlorides are soluble. There are a few exceptions. However, aluminum is not one of the exceptions, so therefore this is soluble. Same is true of sulfates. Most sulfates are soluble. There are a few exceptions. Aluminum is not one of them. Therefore, it's soluble. We mix these solutions together. There are no ions that form insoluble combinations, so there are no precipitates formed. We can write no precipitate. We can write NR, which means no reaction, none. All of these are acceptable. I get across the idea that all of the possible cation to anion combinations are soluble. Next problem. We identify the ions in solution. We have copper 2+ and nitrate in the first aqueous solution. The second aqueous solution has potassium ions and carbonate ions. Let's write all the possible cation to anion combinations. Considering their solubility, we know these are soluble because they're 1A metal salts. We know the nitrate is soluble because all nitrates are soluble. Copper carbonate. Most carbonates are insoluble. The only exceptions are 1A metals and ammonium. Therefore, this is insoluble. The insoluble compound identifies the precipitate. Here we are adding 3 solutions together, so there are more possible cation to anion combinations, but we still proceed the same way. And here's the result. I've put them all in a big beaker, specifically such that the cations are here on the left, the anions on the right, because we know the cations always are first in our formulas. So we're going to consider barium with chloride, barium with nitrate, and barium with sulfate. Next, we can consider silver with chloride, silver with nitrate, and silver with sulfate. And finally, zinc with all the different anions. Then we go through and determine the solubility of each of these salts. The insoluble compounds are our precipitates. So we have barium sulfate, silver chloride, and silver sulfate. Same process, only complicated by the fact that there's more potential combinations. We first identify all the ions present in solution. All right, in writing the ions, I want to bring your attention to the hydroxide ion. For reasons we'll talk about when we get to acids and bases, I like to write the hydroxide ion instead of OH minus as HO minus, and I encourage you to do the same. Don't let it throw you. We have again arranged our ions in the combined beaker such that the cations are on the left, the anions on the right. That will help us remember that when we write the formulas, the cations occur before the anions. We need to consider all of our possible combination of cations to anions. So we want potassium with hydroxide, with perchlorate, and with bromide. In reality, we don't need to do that because we know all potassium compounds are going to be soluble as it's a 1A metal, but I want to show you the process, so I am going to show you all of those. Now lead with each of the anions. And note, we are careful to write the formulas of these ionic compounds correctly such that the positive charge equals the negative charge. Finally, calcium partnered with each of the anions. And here are all our possible cation to anion combinations. We determine the solubility of each. Our insoluble compounds indicate our precipitates.